Yeah, this soil looks really dry out here. It doesn't look like it has much water in it at all.
Yeah, well, we need water. It's an essential ingredient to human life. I mean, it helps us grow our crops, it helps us in our houses, and it just helps us live.
You're right about that. I just hope that the climate engineers are able to supply us with enough water. It looks like we're gonna need like 3 inches per month of rainfall to support life here.
Yeah, remember when the thermohaline cycle shut down?
Oh yeah, I do remember that. That was because Greenland melted, wasn't it?
Yeah.
Okay. Due to our soil analysis, I think a good place to live would be right about here, since we would have a prime crop yield.
Alright, in order to make sure that we have enough rainfall there, we should probably place a mountain range some distance to the east, because that way, via the rain shadow effect, we should expect large rainfall in that region, as water that's carried by air masses from the west of that region pass over the mountain range, rise, cool, and release their water. That will likely create an arid region over to the east of the mountain range, but we aren't planning any settlements there, so that's acceptable.
Well, when we deliver water to Mars, it should naturally lie in the northern hemisphere because that's where the elevation is a little bit lower. So I think we should probably draw canals through the land to make sure that water is delivered in the correct places.
If we want to make sure we have water in the southern hemisphere, we should put a lake right about here.
And we need to make sure that we connect through all of the lakes and rivers that are likely going to form in the craters scattered throughout the plains to make sure that lots of regions have access to water, otherwise trees won't grow and we won't be able to develop a cohesive atmosphere. And we'll also have to check that we're making passes long enough for ocean currents to flow and transfer heat between the equator and the poles. Alright team, sounds like a plan. Let's go do it. Is to use asteroids in order to gather the materials we need in order to completely terraform Mars. Specifically, we're looking at using C-type asteroids. These are called C-type asteroids because they have a very high carbon content relative to other materials that it's composed of. Now, the wonderful thing about carbon is that many carbon compounds are actually greenhouse gases, and these trap infrared radiation within the planet so that it can support liquid water on its surface. Mars needs a greater concentration of these greenhouse gases than Earth does because it's so much farther from the sun than the Earth is. The other great thing about these asteroids is that they contain a relatively high concentration of water. Now, water is, as previously stated, incredibly important for life on any planet. For instance, we need it to grow our crops, we need it for plumbing, and we need it for many industrial processes. And it can also be broken apart to be used as rocket fuel. The reason that we're choosing asteroids instead of trying to bring all of these materials from Earth is that it takes a ton of rocket fuel to lift anything from Earth's surface, so it will save us a great deal of time and energy if we are able to gather these materials in space and send them crashing into Mars. The other benefit of using asteroid impacts to deliver these materials is that it will heat Mars up and possibly restore its tectonic activity so that it can regain its magnetic field, which should help it, one, to hold on to most of its atmosphere, and two, protect us living on the surface from any harmful solar radiation. And for these reasons, asteroid mining is clearly the best way of going about getting water and carbon and all the other materials that we need for life on Mars.
It looks like our climate engineering worked out great.
Oh yeah, you're right. According to my experiment, it looks like this water has high levels of oxygen content, low salinity, and great pH. It's neutral.
Yeah, I mean, I'm reading low turbidity